All right, so this week we're going to be discussing functions in Python. Let's go ahead and get started. So what is a function? So a function can be thought of as a named and stored code block that runs only when it's called. So typically this is a block of code. That you'd otherwise have to repeat in your program multiple times. And thinking about that situation where you might have to repeat the same code block multiple times in your code. Say we didn't use a function for that repeated code. What happens when you need to change a portion of that code block? Say you go through and you realize, oh, I put a bug in here. I need to fix this. What do you have to do in the case that you have repeated code blocks throughout your function? Or throughout your Python script? Well, you're going to have to go through and change it everywhere that the code block appears. And that causes time issues because it's going to take you much longer to go change it in, say, 5 places. And it also introduces the possibility of accidentally creating a bug in one of those instances of that code block, and you don't even know it until you're running your program, and then you run into an issue, and then you're like, wait, I thought I fixed the issue with this code block. But when you have it repeated 5 times, it's easy to make that mistake, or even just miss one. Say you update it in 4 places and you forget to update it in one, then your bug still exists. So functions help make it a lot easier because then you have that stored code block in one place and you only have to change that code one time. And then everywhere that function is called basically makes it so that the code is already changed. So you just have to call the function in that place. You only have to edit the code block in one place, and then you're good to go. So that's the typical use case, basically, when you have a block of code that you need to repeat multiple times. You'll definitely want to put it in a function at that point. So functions are defined using the def keyword. We'll see that in a minute. Functions can optionally accept inputs called parameters or arguments. So you'll hear me say those basically interchangeably throughout the lecture. I'll say both parameters and arguments. You've heard that same term already when we're talking about methods. Say, talking about like a method that we call on a list object or something like that. Methods accept parameters, functions accept parameters. Functions and methods are really similar. It's just that methods are called on an object and they apply specifically to that object type, whereas functions are more general purpose and they can be called on their own. Functions return data to the caller. They always return some sort of data to the caller, whether it's nothing basically that they return, a none object, or if they return something like a string or a number or a data structure, whatever it might be. But functions return something to the caller. And we've actually already been using built-in functions throughout the course. So we know the print function really well. It outputs whatever is entered as a parameter to the console. The stir function, we use that to convert things to a string, to convert the pass parameter to a string. So say we have a number in one of our assignments, we had a number, we needed to convert that to a string in order to iterate over the digits in that number. We use the stir function for converting that number to a string. And then the int function does the opposite of what the stir function does, in the sense that if we pass it a string version of a number, it'll convert that to an integer data type. But the thing about the int function is that it has to be, the parameter passed has to be something where the conversion to an integer is logical. Otherwise, you're going to see an error come out of that function. Something like, can't convert like the string hello to an integer. So when it comes to defining functions are declared using the def keyword as mentioned on the previous slide, followed by the function's name, then parentheses, and a colon. The code that defines the function or the function body is indented underneath the function declaration, kind of like with if statements and for loops that we've seen in the past. Python uses indentation for control of what belongs to what structure, basically. So with a function, you want to indent the code that should be part of the body of that function underneath the function declaration. And then parameters, also called arguments, again, if present, are defined within the parentheses of the function declaration. These parameters can then be used within the function definition. So here I created a very basic function using the def keyword. My function's name is my_function. Then I have my parentheses afterwards, and the parentheses are empty, meaning that this function doesn't accept any parameters. And then my colon, the colon must come at the end, otherwise you're going to get some syntax errors. And then you'll see here I have indented underneath the declaration of my function, print hello world. So this function, when called, all it's going to do is print hello world to the console. Alternatively, I have another function over here that says hello to someone or something. So again, my def keyword, the name of my function is hello. It's followed by parentheses, and this time within those parentheses, I have a name here. And so I have a parameter called name, and then the colon after that to define the, basically show the end of the defining of my function. So this name parameter, you'll see now I'm using within the body of my function. So this function prints hello and then to the name that's entered in the call to hello. So so whatever value is entered for name here will show up in the call to hello, or in the print statement of hello here. So just to make it extra clear here, these are the function names. It shows up here in like a yellow color. So this one over here without parameters is just called my function, and it just says hello world. And then my hello function, it says hello to whoever or whatever name you pass in the parameters for that function. And this is just to call out that that is a parameter right there. So invoking a function, functions are invoked or called using their names followed by their parentheses. So the my function that I created in the last slide, I can call that by just doing the name of my function, my underscore function, followed by parentheses. And when calling that, the code that's inside that function is executed. So in this case, that my function code just prints hello world to the console. So we see hello world printed out here. Now, if the function requires a parameter or parameters, you must pass the values you want to assign to the parameters in the parentheses, otherwise an error will occur. So let's see, in this particular case, we have hello, so we're using the hello function, and this one does require a parameter, that name parameter. So I pass hello world here. So the string that I'm passing in place of name is world. And then we get hello world printed out to the console. Alternatively, I can pass any other string there, and I can say hello to the class and say, and hello class is printed out to the console. So here we see we have, here's the function once again, just to show what's going on here. So the world and the class are what's lining up with name here. So they're basically taking the value of name, so then anywhere name is used within the function definition, it'll refer back to the parameter passed. So since I passed world here for name, that formats in world here, and we get hello world printed to the console. And then same goes for class. When I pass class as the parameter to this function, it'll print that out here. It'll basically format it in as name, and then we get hello class. And then to the point about whether or not your function requires parameters. So remember, the hello function does require a parameter. It has this name parameter here. And if I call hello, like I tried to call my function without passing any parameters, then I get an issue, and then I get an error here. It says type error, hello, missing one required positional argument name. So we need to pass an argument to this function because it is defined as requiring a parameter here. Any questions so far on defining or invoking a function?
Hi, David. It's Hugh over here. Can you please explain the parentheses down there, please?
Which parentheses? These ones here?
On the right side, down
on the right
below. Side? Yeah, there. Yeah, there's like a parentheses.
Yeah, so
after hello, comma, parentheses.
Oh, these ones here, these brackets.
Yes.
Okay, yeah, this is string formatting. I know some of you already have like come across string formatting. I'm gonna basically start introducing some small things here that you can use in your code, and you might want to like research on your own time as well. But yeah, definitely ask whenever you see something that you haven't seen before. In this particular case, what this does is this is a method of string formatting. So we have hello, comma, and then we put in these curly brackets here. Those curly brackets, then when you call the dot format looks for the curly format or the curly brackets in your string, and it'll insert whatever is passed into the format method. It'll put whatever is added in there in place of those curly brackets here. So in this particular case, we're formatting in name. So the value of name will be inserted in place of these curly brackets here. And we can see that right up here where we have hello and then world, because that's the value we assigned. Oops. That's the value we assigned to hello, or to the name here. We assigned it world. So now this would basically be world, and that inserts it in here in place of the curly brackets. So we don't actually see those curly brackets when it outputs, because it's substituted for the name that is formatted into the string. Great question.
Thank you, David.
Of course. Yeah, thank you for asking. Any other questions? All right. So parameters. Again, we can also call them arguments. They're essentially inputs to a function that are used within a function. So order matters. There's a concept of positional arguments, and then there's also keyword arguments. We're going to start with positional arguments here. So in this case, I've defined a function. I've called it display exponentiation, and it takes two parameters, base and an exponent. So this order matters here. So when I call this function, I need to make sure that the first number I pass is the number I want to be my base, and then the second number I pass is going to be the number that I want to be my exponent. And then inside this function, we're just going to print out basically the formula for exponentiation here. So it'll output base for the first squiggly brackets here, exponent for the second squiggly brackets here, equals base, and then remember our exponentiation operator, the double star here, base to the power of exponent will be substituted for these squiggly brackets here. So again, with this format function, order also matters here. I have three sets of curly brackets here, so I need three things in my format function. And the first thing in my format function goes for the first thing of squiggly brackets, then exponent for the second, and then the third thing in the format method goes for the third set of squiggly brackets. So now when I call that, and I call display exponentiation, in this case, I'm passing 5 as my first argument. So that means this is going to be for base. And then I'm passing 2 as my second argument. So that's going to be for exponent. And then we see that base is substituted for 2, or 2 is basically 5 is substituted for base here. So we'll see the 5 in this part right here. And then 2 is substituted for our exponent. So we'll see the 2 in that part of our string. And then we actually do the exponentiation base. So this would be 5 to the power of 2. And we output 25 there, because 5 squared is 25. Then alternatively, if we call display exponentiation just by flipping our parameters here, then we actually have 2 as our base and 5 as our exponent. So then in our output down here, we see 2 as our base, 5 is the exponent, and then we get 2 to the 5th power, which is 32. So just be careful when you're using positional arguments. You need to make sure that the arguments that you enter are in the order that they are defined in the function definition. Parameters are named, so you can't repeated names of parameters are not allowed. So in this particular case, I defined an invalid function. I just named it invalid because I knew it was going to be invalid. And I put x as the first argument here, but then I tried to also put x as the second argument here. You'll see that it's underlined in red right here. And when I hovered my mouse over it, it showed me that duplicate parameter name. That's the error that I'm getting. And this basically means my code's not correct. It won't run. It'll cause an error if I try to run it. And so this function will essentially do nothing. So since parameters have names, make sure that if you need to add multiple parameters, don't repeat the same name multiple times. They need to have different names. And then instead of invoking a function with positional arguments, you can also use keyword arguments or the parameters names when you call the function. So in this particular case down here, I want to do display exponentiation, and see I'm using the keywords here that are present in the function definition. So I want base to equal 10. So I'm explicit about that here. I want base to equal 10, and I want exponent to equal 2. So these names match the same value, match the same names in the function definition. And I just say I want base to be 10, exponent to be 2. So then we see that that's exactly what we get in our output here. 10 to the power of 2 is 100. Alternatively, since I'm using keyword arguments, now I don't have to worry so much about the order of the arguments here. So in my call to display exponentiation here, I want my exponent to be 2 and my base to be 10. I just switched the order here, but this is basically the same call. It's just that I switched the order of them, but since I'm using keyword arguments, the order no longer is important in this particular case. So we get the same output here because I still have the same exponent and the same base. So we still get 10 squared equals 100. So two different ways that you can do it here. Oftentimes you'll see people mix both. Some functions do require you to use keyword arguments, and you'll see that in an error. It's more of in packages, which we'll be learning about packages and stuff in a couple weeks. But certain packages will require that you use keyword arguments. Most functions, though, will accept positional or keyword arguments. Yeah. So here I've now boxed in every reference to base in red. So base is the first argument in display exponentiation. So if I'm using positional arguments, the first thing in the parentheses here, the first value that I pass in the parentheses is going to be my base value. And then if I'm using keyword arguments, whatever I set base equal to in the keyword argument, that's what base is assigned up here. So we have a couple options here for how we reference base. And then same goes for exponent. Now I've boxed exponent in with green. So exponent is the second argument in our display exponentiation function. So if we're using positional arguments, whatever we pass as the second argument is going to be our exponent. So in this case, it's 2 for this invocation up here. In this case, it's 5 for this invocation down here. And then if we're using keyword arguments, whatever we assign to exponent in our keyword argument is going to give us the is going to be the exponent in our call to the function. So in this case, we've assigned, in both of these cases, we've assigned it 2. Yeah. Any questions on that? All right, cool. So parameters continued. Parameters can have default values. So if a parameter is given a default value, it becomes optional when invoking the function. So in this particular case, now I have this this function say hello defined. So I define say hello in my parentheses. It accepts one parameter name, but this parameter name now has a default. So its default value is world. In this particular case. So it'll print hello, whatever name. This is a lot like the hello function I already created earlier. This one's just called say hello. So they are two distinct functions. And this one here, it has name defaulted. So what that basically means is if the parameter is given as a default value, it's now optional. So when I invoke say hello, I can choose whether or not to pass a parameter or not. If I don't pass a parameter, then what I get is just the default value. So name's defaulted to world. So if I say hello without passing a parameter here, I get hello world. But I can alternatively call say hello passing a single argument, and I can pass David in there. And now my say hello function says hello to me. It says hello David. So keep in mind that if you have something where in most cases or in many cases, not even most, you want name to be, or you want your parameter to be a particular value, and you don't want people to always have to specify that particular value, you can have a default argument there. And then when people invoke it, they don't have to use, they don't have to add that parameter into the function's signature. So see, in this case, no parameter pass, so we use the default value. In this particular case, there's a parameter pass, so we use the value of the parameter. So if creating a function with both required and optional or defaulted parameters, define the required parameters first and optional parameters last. So down here, I've tried to define a function called greetUser. And it accepts 2 parameters. One of them is greeting, and greeting has a default value of hello. And then the other one is name, and name does not have a default value. Therefore, it is a required argument. But you can see here, it's underlined in red. It's telling me that I've done something wrong here, and that's because I'm putting a positional argument or a required argument after a default argument, and that causes issues for the Python interpreter. So just don't do this. Don't add a defaulted argument with a required non-defaulted argument after it. We would want instead to flip those around, and now this is a valid function. So for greet user, now it still accepts the same parameters, but I've correctly now put name as the first argument because name is a required argument. It doesn't have a default value. And then I've put greeting as the second argument, and greeting does have a default value, and that is hello. So now this function, when run, it'll print the greeting, comma, the name. So it'll say, it'll say hello, and then whatever name is entered. If greeting isn't passed, and if greeting is passed, then we could have a different greeting in there. So now when we invoke that function, I want it to greet David. So it just says hello, David. And because I didn't pass a second argument here, we just use the default value for greeting, and we just get hello, David. But instead, if I want to, greet David in some other way, say David's a close friend, and so I feel like being less formal and saying hey to David instead of hello to David, then I can greet user, and I would pass David and hey, and now hey is taken in place of hello in that greeting. We use the value passed instead of the default value. So now we get hey, David. Any questions on this slide? All right. So now the return statement. As mentioned earlier, all functions return data to the caller. The return keyword allows us to specify what that data should be. So functions without a return statement always return none. So going back to our greet user function, there was no return statement in the greet user function. It didn't explicitly return anything. So any function that doesn't explicitly return something will return none. So in this particular case, I call greet user, and the return value is what I set it equal to. So I call greet user, and return value is equal to my call to greet user. So whatever is returned from greet user will now be stored in my return value variable. So I do that. I store the return value of greet user in return value. And we see that it prints hello David because that's what this function does. It prints hello David to the console, and then or hello to whatever name is passed up here to the console. And then I check, is my return value none? And it is. My return value is in fact none. We get true there. So that's showing that greet user, it did return something, but it just returned none because there was no return statement explicitly saying to return some value. And an important note to make here is that the output printed to the console via the print function does not equal the return value. So hello David was printed to the console. That's not actually returned from the function. That's just printed because there's a print statement within greet user. So don't confuse a print statement with a return statement. Print statements don't actually return anything, whereas a return statement would. So in this particular case, even though we see hello David outputted to the console here, return value is still none. So now functions with a return statement return the value specified after the return keyword, which can be stored in a variable. And an important thing to note here is can be stored in a variable. It doesn't have to be. So now I've defined another function called get user greeting. So now I want to get a greeting. So it's going to return something here. Often you'll see getters, setters and getters. We'll talk about setters and getters next week when we talk about classes. But often with a get function, it'll return something because you want to get that value. You want it returned from that function. So in this particular case, it's similar to the greet user function. It just has a different name. So it's get user greeting. Name is the first required argument, and greeting is a second optional argument with hello as its default value. And then in this, instead of just printing it out, now I'm returning that string, that formatted string here where we format in the greeting for the first set of squiggly brackets and name for the second set of squiggly brackets here. So this will, instead of just printing to the console, it'll actually return that value. So now what I can do here is I can set user greeting equal to get user greeting world. And so when this function is invoked, whatever is returned from this function will now be stored in the user greeting variable. So now if I output user greeting here, we'll see that user greeting now has the string hello world stored in it. Alternatively, if I don't assign anything, if I don't store the invocation of user greeting to a variable, then it's just going to output to the console, and I don't have any way to reference that later on. I could invoke the function again to get this to output again, but just keep in mind when you call get user greeting or anything with a return value and you don't assign it to a variable, you'll often see it output to the console. So note that the return statement is not printed to the console when it's stored in a variable, otherwise it is. So in this case where I did store the return value in the variable user greeting, we don't see anything printed to the console here between these two lines. The only time we see it printed to the console is when I output user greeting right here. But in this particular case, because I'm not storing the return value of my call to get user greeting, because I'm not storing it in a variable, it still returns this, so it outputs it to the console. It's almost like the same thing as where I'm calling user greeting here. Because I'm calling user greeting here, it outputs hello world to the console. Here, I'm just calling get user greeting. It returns hello world and it outputs that to the console because it doesn't have anywhere to store it. It instead just prints it to the console in this particular case. But again, something important to note is if you're using a print statement inside of your function, that's not actually going to be returned into a return value. That's just output to the console, and then it's kind of lost forever after that, if you will. It's not something that you can store into a variable when you're using print, only when you're using return. And then something else to consider is that the return statement will only return a value specified if the return statement is actually reached in your code. Otherwise, it's going to return none, like a function that doesn't have a return statement, because it never hits that return statement, so it doesn't return a value. So in this particular case down here, I've defined another function, or I've updated get user greeting, sorry. I've updated get user greeting to have an if statement in here. Now I'm basically making sure that the greeting passed is actually a valid greeting. So I want to make sure that greeting is in hello, hey, hi, good morning, good afternoon, or good evening, because those are all ways that we could greet somebody, right? So in that case, then I return the same thing as up here. I would return the greeting string. If instead if I call get user greeting with an invalid with something that's invalid here as an invalid greeting, so if greeting in this if statement evaluates to false, so we never reach my return statement down here, we don't see anything output to the console like we did up here because we never reached the return statement. So this is returning none, and by returning none, it just doesn't output anything to the console when you don't store it to a variable. But in this particular case here, if I do want to store that to a variable, get user greeting again to David, and I'm going to try to greet David with goodbye, and I store that in my user greeting variable. Now, if I check, is user greeting none? It is, because it never reached the return statement, because goodbye is not a valid greeting. So this if statement evaluates to false, so our return never executes. And so it just returns none because it didn't reach a return statement that returns a legitimate value. So instead, it returns none. Any questions on this? All right. So return statement continued. We can return multiple values with a single return by separating return values with a comma. So here I define a function called get integer quotient and remainder. So so the quotient is, in case you're not too familiar with the math around it, a quotient is the output of a division operation. And in division, you have your dividend, which is, your numerator is another way to put it, whatever value's on top of your division. Your divisor is your denominator, or whatever's on the bottom of your division. And so I'm getting the integer quotient and the remainder after that integer division. So in here, I return the dividend floor division using integer division here. Remember the double slash from the first week. So dividend divided by divisor, so floor division divisor. And then I'm also returning, because I have a comma here, now I also want to return the dividend mod the divisor, which, remember, the modulus operator returns the remainder of that integer division. So when we do this, the value is returned in the form of a tuple. So in this case, I'm not actually storing anything in the variable. So remember that if we don't store it in a variable, it'll output to the console. So we get integer, quotient, and remainder for 10 and 3. So I want to divide 10 by 3 using integer division, and I want to get the both the integer division value and the remainder. So 10 divided by 3, floor division would come out to 3 because 3 goes into 10 evenly 3 times. So so in that case, we get 3 for the first value because that's the dividend floor division divisor. And then the second value returned is our dividend modulus divisor. So it's the remainder of that integer division. So it's 1. Because if we think about it, 3 goes into 10 evenly 3 times. So because 3 times 3 comes out to 9. And then there's a remainder of 1 there. So we get 3 and 1. Now we can unpack this returned tuple here by assigning to multiple variables. So in our invocation here, now I'm assigning it to a variable, and I do quotient, comma, remainder. So that means that that means the first value returned, which is, because remember tuples are ordered. The first value returned is this value here, which also corresponds to our dividend floor division divisor. So that's going to be our quotient is the first value. And then the second value will be our remainder, which is dividend modulus divisor, which is going to be our 1 in this particular case because I'm still doing 10 and 3. So now after doing that, if I output quotient, I see that quotient is 3. And if I output remainder, I see that remainder is 1. So we can return multiple values here. If we return multiple values and without storing it in multiple variables, then it'll output as a tuple here. But if we store it in multiple variables, this is called unpacking, then we'll see that we have quotient as 3, remainder as 1. So you can kind of look at it as here's the 3 here, here's the 1 here, and yeah, so we've kind of unpacked that tuple. Any questions on this slide? All right, cool. So now documentation strings or docstrings. So documentation strings or docstrings for short are essentially comments used to document a function's usage. Typically they're wrapped in triple quotes. Here I've done triple double quotes. You could also do triple single quotes. It's totally up to you, but typically it's going to be in triple quotes. And it contains 1 to 4 parts. It'll always contain a description. You should always at least have a description in your docstrings. If your function has parameters, you want to include those parameters in your docstring as well. And then same goes for same goes for a return value. If your function produces a return value, you want to include that in your docstring. And then errors or exceptions raised by the function, if applicable. So we haven't gone over error handling or raising errors or exceptions and errors at all yet in this class. I'm hoping to cover that soon, but so just don't worry about this part right now, but just keep in mind if you ever write a function that explicitly raises a function, you'll want to include or raises an error, sorry, or exception. If you ever make your function explicitly raise an error or exception, you want to make sure to document that in your docstring and explain what situations that might occur, that error might occur. So down here, I've defined get user greeting. It's the same function that we had in previous slides, but now I've added my docstring. This whole thing here is my docstring. This see, I wrapped it in triple double quotes. I could have done triple single quotes. I just always do doubles. And then here's my description right here. So this function, it's a function to build a greeting to a user using, and then these arguments down here. These are my parameters. So I've specified args, and then indented under that, I have param name and param greeting. So my param name is a string representation of a user's name, i.e. the user to greet. And then my parameter greeting is the string greeting to use when greeting the user, and it defaults to hello. So notice here that I called out the data type that these parameters should be, and if it has a default value, I specified what the default value is. And now we have our return value down here. So in my return section here, I specify that it returns a greeting in the format greeting name with an exclamation point at the end if a valid greeting is entered, else none. Because remember, with this particular code right now, I have an if statement, and I have if greeting in, hello, hey, hi, good morning, good afternoon, good evening. So if the greeting entered isn't one of those, then we're never going to hit that return statement. So the function would just return none. But if we do hit that return statement, then I'm clearly specifying here that this is what would be returned, greeting, comma, name, exclamation point in the form of a string. So something to note here is that the formatting for a docstring is flexible. This is just how I write mine. So I write mine just like this with triple quotes. Then on the next line, I have my description. Then I have a blank line, and then I have args to be explicit about what are my parameters. And then I have return to be explicit about what's returned from the function. But this is just how I write mine. There's not necessarily a right way to do it, but just make sure that you include all these components and just come up with something that makes sense to you. Just include all the components and be consistent. Nobody wants to read docstrings that, if someone's going to jump into your program and they're going to try to look at your documentation, they don't want to have to try to figure out what you're trying to say in each docstring. You want to make sure that the docstring is consistent across your functions, so that once they get the hang of, okay, I've seen a couple docstrings from this programmer, now I know what to expect in their docstrings. Feel free to take my format here. It's not like I own a copyright on this. Use what I use here if you like it, but just know that the formatting is really flexible. Do what makes sense to you. Just be consistent and include all the necessary components. You always must have a description. If your function takes parameters, which this one does, specify the parameters in there. If your function has a return statement, specify the return value, because generally, if it doesn't have a return statement, generally everybody in programming is going to know that that's going to return none. So you don't need to specify that. It returns none when there's no return statement. Or any questions on that before I move on?
Yeah, sorry. Yes, David, I have a question.
Yeah.
Can you please, in the way that I can easily understand, what is the difference between the return statement and the print statement?
Yeah, so a print statement, all the print statement does is it outputs to the console. Remember last week when we were talking about file input and output, the print statement is a form of an output, and it just outputs to the console. That's all it does. It prints to the console, and it doesn't do anything else. A return statement actually returns that value from the function. So it's basically like the function produces that value and sends it back out. It's not just sending that value out to the console. If you don't store the value somewhere, it will happen to be outputted to the console, but that's not exactly what it's doing. It's actually sending data back to whoever called the function. The print statement doesn't do that. The print statement just outputs something to the console. It doesn't send something back to the person who called the function. Does that help clarify a little bit?
Yes, absolutely. Thank you.
Awesome. Thank you for the question. Really appreciate the questions. Anybody else have any questions? All right. Yeah, thank you. Thanks again for the questions. I really want to hear all the questions you have. Remember, if you have a question, chances are somebody else has that same question. They just don't want to speak up. Looks like Tabiso, you unmuted. Did you have a question?
Can you hear me?
Now I can, yeah.
Oh, sorry. I wanted to ask if, in fact, when it is important to write a document string in the coding.
So anytime you have a function, or we'll also talk about classes next week, but anytime you have a function or class, right now just think about it for functions. Anytime you have a function, you want a docstring. So even if it's the most simple function ever, it doesn't accept any parameters, it doesn't return anything, still just have a little docstring with a description of your function. It's just a best practice for documentation. It makes it a lot easier to read somebody else's code, because especially when you get into complicated functions, you don't want to spend the time reading through that code trying to understand what that function does and trying to understand what the parameters mean and trying to understand what the return value is. If someone just takes a minute or two when they write that function, they understand it very well. When they write that function, then they know what that function's purpose is. They know the arguments the function accepts and what data type they should be, and if they have a default value, and they know what that function returns. So you want to just take the time to make it easier for anybody who reads your code, including yourself. Maybe you come back after some time and you're like, why did I write this function? What does it do? What parameters does it take? What does it return? It helps you and it helps other people. Remember that reading code is actually, once you get really into the thick of programming, you're going to spend a lot more time reading code than you will writing it. So documentation is very important.
All right, a follow up on that one. So taking an example of what you have put on the screen, there's a get user greeting on top, and then a docstring and some code below. This means that this is the fashion I can take in writing code, such that every line has a description, and the program will not confuse the nodes, the comments with the code, right?
That's correct. Yeah. So here, having it wrapped in triple quotes here, this is actually a way that you can have a multi-line comment. I know we haven't really talked about comments here, and you can definitely look up comments in your own time. I highly recommend it. It's super useful for documenting code. But yeah, since this is wrapped in triple quotes, Python doesn't interpret this as code. It just interprets it as a multi-line comment. So it won't actually do anything with this multi-line comment here. What it actually will do is store it in the double underscore doc double underscore property of our get user greeting, but it's not going to actually evaluate it when the function is invoked. So when we invoke this get user greeting function, it's still going to act just like it did on the previous slide before I added my docstring. This is just for documentation purposes, so that when I come back to read my code and try to remember what did I do here, then I can clearly remember that by reading something in, human readable language. Of course, when we get our experience with programming, it's just like another language. You get used to reading it, but it's still always easier to read it in a language that we're more familiar with. For me, it's English. I don't know, maybe you have a language that is your preferred language. Feel free to write your documentation in that language. Just make sure that it's something that's easily readable by everybody who's going to be working on your project. So, if you're working with a bunch of English speakers, then do English. If you're working with a bunch of Swahili speakers as their native language, you could use Swahili. Whatever makes sense to you, whatever makes sense for the project, just always include a docstring so that people can easily tell what your function does. Great question, Tommy. So thank you.
Great.
Any other questions? I'm loving it. Keep them coming. All right. Cool. So docstrings continued. So docstrings or functions have a special attribute. This is a double underscore here. It's a double underscore doc double underscore with the value of the docstring that you entered when defining the function. So you can use this attribute to learn about new functions. So whenever you're trying to figure out what a function does, you can print out the get user greeting dot its docstring. Because remember, when attributes are almost like methods. You use dot notation to understand an attribute of some value out there. And you'll notice in PyCharm that any special attribute will show up in, or any special attribute, special method, or special function will show up in a different color here. So, but yeah, we see here I'm printing get user greeting dot, so I'm getting the double underscore doc double underscore attribute of the get user greeting function. Notice I don't include the double parentheses after this. You don't want to include your parentheses or any parameters when you're trying to get the doc variable. You just use your function name, then you get the doc attribute off of that. So now when I print that out, this is the output I get. It's the same string. It's the same doc string that I had created on the previous slide, but now it's like actually printed to the console. So function to build a greeting to a user using, and then my args, my return value, all that good stuff. So this is super helpful because sometimes you don't have the source code to look at right in front of you, but you have access to the function. So if you don't have the source code in front of you, but you want to understand what that function does, you can print out the function's doc attribute and then you can see the documentation that someone wrote for that function. Hopefully they documented it. If they didn't, then they're not following best programming practices. But you know, you all will make sure to follow best coding practices, I'm sure. So if you ever forget what your function is, you can't look directly at the source code, or you don't want to take the time to find the exact file and open that file up, you can just do the function name dot its _ doc attribute. So any questions on Docstrings before moving on to scope? All right, sounds good. All right, scope. So the scope of a variable or a function defines the context in which that variable or function is recognized. Variables we've defined and used in class so far have a global scope, meaning they can be referenced from anywhere in the code. If a variable or function is defined within a function, it is part of the local scope of that function and cannot be accessed outside of that scope, i.e. outside of the function. So this example up here, this one, I'm creating a variable x, and since it's at the root part of my file, I define x equals 10, and then I print out x, and then we're going to see that, and then I'm also creating a function, myfunc, and it doesn't accept any parameters, but it also prints out x. We don't see any errors here because x is in the global scope. So we see that x can be referenced anywhere in the code now. It can be referenced inside this function or outside the function like it is up here. Now I print x and it'll output 10, and then when I invoke my function here, it'll also print x and it outputs 10. So we see here that when I run this file, the printx statement that's happening up here is outputting the first 10, and then the invocation to my function here, or my func here, is printing x here. We get 10 in both cases because we've defined x in the global context of the function, or the global scope of the file. Sorry, not the function. It's in the global scope of the function. Now, if we instead defined my function as having a locally scoped variable, so I just was explicit about the name here, it's a locally scoped variable. It's scoped to the local scope of my function. So so this variable stored in it, I'm saying I am not accessible outside of my func here, and then I print locally scoped variable here. I invoke my function here, so you might think, oh, locally scoped variable has now been created, so now I can reference that outside of my function. That is not true. It will get this unresolved reference locally scoped variable because we haven't defined that in the global scope of our function. We only defined that variable within our other function. So that means it's not available at this level of the code. It's only available at this level of the code. So if you define a variable within a function, it's only going to be available in that function. It won't be available outside of that function. Oops, I thought there was more on the slide. We're going to hold questions for now because hopefully it'll get more clear on the next slide. So scope continued. You can have multiple variables with the same name, one in the global scope and others inside the scope of functions. This is called shadowing. So in this particular case, I have x equals 10. And then in, you know what, I do want to go back here and make sure that global versus local scope makes sense first before I talk about shadowing. So what questions do you have about global versus local scope? All right, yeah, it's definitely a complicated concept.
Sorry, David, global scope means that you define the variable before the def function, yeah?
Yeah, so here I've defined it at the outermost scope of my function. So this is it's not indented underneath anything else. It's just, at the first line in my function, say I've defined x equals 10. It's not nested underneath another function. So that means, so when I define it not nested underneath a function, it has the global scope. So it's available anywhere inside of my code.
Okay, I got it now, thank you.
Yeah, of course. Yeah, and then if I define the function instead inside of or if I define the variable instead inside of a function, then it's only available within that function. It's not available outside of that function. Thanks for the question. Any others? Yeah, this is definitely a complicated concept. It's one of those things that it doesn't always make sense on paper. once you get some experience with it, it makes a lot more sense. So as I was saying before, you can have multiple variables with the same name, one in the, go ahead.
Yeah, thank you. Can you give us a demo on how on a console, you in fact, on the, where you write the code, you define both a global one and a local one? Well, I saw a screenshot, but I wonder if below and above those, there should be something particular that one has to write.
Yeah, I took a note of that to demo scope at the end of the class, and I will definitely demo that. We're just about at the end here. I think this might be our last slide.
All right, thank you.
Thanks, Taviso. So yeah, you can have multiple variables with the same name, one in the global scope and others inside the scope of functions. This is called shadowing. So in this particular case, I've created a variable x and I've set it equal to 10. But now inside of my function, I've defined my func and I've created this variable x equals 20, and I'm printing out x in this function. So you'll see here, this is underlined in gray. This is not an error. This is just warning me that I'm shadowing the global scope variable with a local scope variable. But that doesn't mean that I'm going to reassign the value of my global scope variable inside of my func. So here I've called my func and printed x. So in the call to my func, it outputs 20 because it's using the locally scoped version of x in my func. But because I haven't referred to the global x explicitly, it doesn't reassign the value of x, because remember, this has a local scope here. It's only scoped to this function. So operations that happen within here are only scoped to this function. So while I assigned 20 to x inside of my function and printed that out, and we see that output here, when I print x after invoking my function, I still get 10 because that's referring to the global scope. So just to be explicit here, that gray underlining there, all it's saying is shadows name x from outer scope. So it's telling me that I've created a variable inside of my function with the same name as a variable that's outside of my function. So it's shadowing it. So that means it's basically what, in the context of my function scoped, in the context of my func's scope, x is going to be equal to 10 because it's shadowing the global version of x. Now we can get a reference to a global variable from within a local scope using the global keyword. So now in this particular case, I'm doing basically the same things where I have x equals 10. But in here now in my func, I've specified global x here. So what this global keyword is saying is use the global version of x inside of this function. So now I am referring to this x out here. So now when I reassign the value of x to 20, and then I print x, it's going to affect the globally scoped variable because I'm using a global x inside of my function. So now when I invoke my function, it reassigns x to 20. And when I print x down at the bottom here, this also outputs 20 because I used the global x in here, and then I reassigned that value of x, which is now referring to the global version of x. So it affects the global x up here. So we print 20 in both cases. Questions?
Oh, I wanted to ask a question, but now it's fine. You answer my question. It's okay.
Okay, cool. Well, I'm glad that works out well. Any other questions? All right. So some additional resources here. We've got a link to functions on W3 Schools. We've got a link to the function exercises on W3 Schools, and we have a link to learning about scope on W3 Schools. I highly recommend that you take the time to go through these additional resources. They help immensely in understanding these concepts. They have examples as you go. You can run the code examples with a try it yourself button. I'm just gonna kind of show you, because I don't know that we've talked so much about, I don't know how many of you have actually gone to W3 Schools and looked at these sample resources, but we're getting to the part in the course now where I think it's very important that you see the value of W3 Schools. So in here, it talks about a function. And then here, there's this try it yourself button. The try it yourself button gives you like a code editor here, and it says like hello from a function. We can edit the code in here. I made this edit, and then I can run this code, and then we'll see how that changes the outputs of the function here. So see, now we see I made this edit here. So I highly recommend going into W3 schools for learning about this, because you can have this, you can play around with arguments or parameters. Yeah, and it just like it might help clarify some things. I am not the best at explaining things sometimes, and I know that. So I highly recommend that you come in and try seeing it from a different source. Maybe it helps to read it yourself, and they have some try it yourself examples where you can then, like I showed here, it'll give you the code, and then you can edit the code, play around with it, see how it should work, see how you can break it, fix it, etc. Yeah, and it talks about keyword arguments. Once you get down to this point, don't worry so much about arbitrary keyword arguments. We're not worried about that right now. But default values, passing lists as an argument, etc. So it's super helpful. Recursion, definitely high level. Don't worry if you don't understand it. Not going to cover that in this class. That's a high level concept. So that's something that I strongly recommend studying on your own time when you're very comfortable with functions, but maybe not yet. All right, so I know Tabiso wanted me to demo scope quickly here. So let me show you some examples of scope. Let me just comment this out here. This is just what I was using for creating the slides. So in this particular case, you'll see here that everything here is commented out. This like hashtag symbol here that comments everything out. So this code won't be evaluated. It's just a comment. So here, looking at the scope, all I have is I have x equals 10. So this is in the global scope. See, it's like not indented under anything else. And then I have x equals 20 down here. This is in the local scope because it's indented underneath my func. So it's only present in the local scope of my func. So now if I run this file, sorry, the Zoom windows are getting in the way of this. Cool. There we go. So now if I run this function, we see that it just outputs 20 and 10 because we invoke my function. So this invocation of my function, x is equal to 20 in its local scope, and we print x. And then here, where we're printing x, we're referring to the globally scoped. So here's something that kind of helps. If you highlight this variable, it's hard to tell, but this x is highlighted ever so slightly because I have my cursor next to that x. So it's telling me, PyCharm is telling me that that's the x that's referred to there. But if I put my cursor here on this x, it's showing me that I'm referring to this x up here, the x in the global scope rather than the x in the local scope. Now, if I do add global x here, now see that now that my cursor is next to it, it's highlighting all instances of x because now this version of x refers to the same version of x throughout the code. So putting my cursor next to that x shows in a very light, almost red highlighting that it's the same x throughout the code here. So now if I run this code, we see that it's 20 because I set x equal to 10, and then I define my function here, and then I call my function. And because I've called my function now, this code is executed. We took the global x, reassigned x to the value 20. So we've given x the value 20. Then we've printed that x, and now because we've already invoked my function, so we've already reassigned x to 20. Now we see print x here. Something that's important to note here is the order matters. So if I put my print x statement before the invocation of my function, sure, I've defined the function up here, but because I've never invoked it yet, this code has never actually been executed yet by the time I get to this print statement. So this is still going to print the original value of x. Let's just see that. So yeah, because I've never invoked my function yet, I've never reassigned the value of x here, because this code, remember, the code inside a function only executes when you call the function. But now say I want to say X after calling my func. And then I can do star X here. Now if I run this, we'll see that it has been updated to 20. So something important to note. Yeah. Does that help with scope a little bit?
Oh yeah, thank you.
Awesome. Anything else I can demo before going over the assignment for the week? All right, let me just real quick review this here. Just want to make sure. Okay. Not much else I can think of demoing right now, and we're also we're close to overtime, so let's move on to the assignment, so then we can go on to the assignment answer from last week. So week 8 assignment functions. So for each of the below questions, write a function to solve the use case at hand and provide a few examples of using the function. The questions will get increasingly challenging, both technically and in terms of being less descriptive as to what is required to accomplish the task as you progress through the assignment. Make sure to document all of your functions thoroughly with Docstrings. So question 1 here, write a function that accepts 2 arguments, a numeric value as well as a list of numeric values. And this function will be used to multiply each value in the list by the number passed and return the resulting list after this multiplication has been applied. For example, if I gave the inputs 2 and 1, 2, 3, 4, 5, the result that the function returns should be 2, 4, 6, 8, 10. Basically, you takes this value and multiplies each value in this list by this value, and then it returns the list after that modification occurs. For question 2, I want you to write a function that converts a temperature entered in Fahrenheit to Celsius. So just look up the formula for that. I didn't want to include it here because it's readily available on the internet. But yeah, so just write a simple function that takes a temperature in Fahrenheit and returns that temperature in Celsius. So then for question 3, create a function that accepts 3 arguments corresponding to the current temperature in degrees Fahrenheit or Celsius, an indicator telling if the temperature is in degrees Fahrenheit or degrees Celsius, and the current weather. It must be one of cloudy, raining, or sunny, and prints out what the caller should wear based on these values according to the following. So first, if the temperature is in Fahrenheit, use the function you created in question 2 to convert that temperature in Fahrenheit to Celsius. And then if the temperature is below freezing, output, it is probably best to stay inside. Otherwise, output, it's warm enough to go outside. And then also, in the case that the weather is sunny, output, and you should bring sunglasses. In the case that the weather is raining, output, but you should bring an umbrella. In the case that the weather is cloudy, output, you do not need to bring an umbrella, and you may not need sunglasses. We all know it can still be quite bright when it's cloudy out, but yeah. Then additionally, in the case that the temperature is below 10 degrees, and this is degrees Celsius, because remember, we need to first convert from Fahrenheit to Celsius if it's entered in Fahrenheit. So in the case the temperature is below 10 degrees Celsius, output, you should bring a jacket. In the case the temperature is above 10 degrees Celsius, but below 15 degrees Celsius, output, you should bring a sweatshirt. And in the case the temperature is 15 degrees or greater, output, and you don't need any extra layers. Cool. And then for question 4, a factorial denoted by an integer followed by an exclamation point is the product of an integer and all of the integers below it. For example, factorial 4, denoted as 4 exclamation point, is equal to 4 times 3 times 2 times 1, which is equal to 24. Note that 0 factorial is equal to 1. Write a function that calculates and returns the factorial of a number. Do not use an existing function for this. Come up with the logic yourself. There are existing functions out there in certain packages, which I won't name right now, that will do this factorial for you. Don't do that. I want you to come up with the logic on your own. Part of this, it's not just testing functions, it's testing your ability to do all the things we've learned so far in class. And then for question 5, write a function that can convert between US customary units and metric units. Here's a link to various conversion tables, include the ability to convert between at least the following: feet/inches and meters, and vice versa, miles and kilometers, and vice versa, fluid ounces and milliliters, and vice versa, and gallons and liters, and vice versa. So just capture all these use cases. Clearly here, I'm not telling you what inputs you might need. I'm not telling you what what kind of return statement to have. So I'm intentionally making it more and more vague, and I want you to kind of think about what needs to happen inside the code here to get this to work. Any questions on the assignment this week? All right. So I'm going to go ahead and stop recording, and I will review the answer to the assignment from last week. So thank you everyone for joining. I appreciate your time. Feel free to reach out with any questions, and I will email out the link to the YouTube video as well as the assignment and slides after lecture.